we would like to compute this integral over the region D of the integral of the two variable function e to the minus x plus y, where D is this region. It's a bounded region in R2. What does it say here? It says that we need x and y such that x belongs to the interval minus 1 to 1, takes the values from minus 1 to 1 including these values, and y from minus 1 to 1 including the boundary values. And this region is a rectangular region over here, you can see. So we would like to compute the integral over this region of this function here. So the integral simply becomes, we have that x goes from minus 1 to 1 and y goes from minus 1 to 1. So the the derivative, this differential here is dx dy. When we have a double integration, we can do the following. We can first compute the integral that lies inside, so this integral, I will show you in 1 second. So we can first compute this integral, and then we start from within and we go towards the outside part of the integral. So this can be written, the integral from minus 1 to 1. This is e to the minus x times e to the minus y dx dy. We have this function e to the minus y, and inside the differential is dx. So e to the minus y can go outside. We can pull it outside the integral. So this should be e to the minus y. Then we have integral from minus 1 to 1, e to the minus x dx dy. We can compute this integral. So this is minus e to the minus x minus 1 dy. We can compute this quantity over here. So this is e minus e to the minus 1 dy. This is just a constant. We can take the constant outside the integral, so it's e minus e to the minus 1. And we have the integral from minus 1 to 1, e to the minus y dy. So this integral is minus e to the minus y minus 1 to 1. And this is e minus e to the minus 1. So this is e minus e to the minus 1 raised to the power of 2. So the integral, capital I, is e minus e to the minus 1 squared. So we have computed the integral. We can see the steps. We would like to find the integral over this bounded region in Euclidean space R2. It's a rectangular region. We have the bounds of integration for variable x and the bounds of integration for variable y. We can compute the first integral which lies inside, and then go towards the outer integral. So we compute firstly this integral over here. Then this is a constant, we can take this out of the integral, and then we compute the other integral from minus 1 to 1 of this function here. And doing some trivial algebraic manipulations, we end up that this double integral is e minus e to the minus 1 squared. Also, I would like to say that if we interchange the order of integration, the result should be the same here, because this function e to the minus x plus y, when x and y grows, we don't have any particular problem. The function goes to 0 as the two variables go to infinity, to plus infinity. So either way, you can try to start to interchange the order of integration and see that if you interchange the order of integration and you compute the integrals, then you obtain exactly the same result that we have obtained here. So this is the first example. I will make another video with another example.